Welcome to the class of computer programming, and in today's class we'll be dealing with functions. This is where we are at regarding the syllabus. In today's class we'll mainly be looking at what is the general form of functions and what are function prototypes. This leads on to the next topic in our syllabus, which are pointers. That will be dealt with in the next class. But today, the focus is on functions. Now, what is a function? A function is simply a block of code. And this block of code performs a given task, a specific task. Now, you may not have known it, or you may know from the beginning, because it's mentioned at the beginning of this C programming course, that you have to have a main function in your code. So you have already been using functions. Main function is, of course, a function. So you more or less know what happens inside a function. There will be certain statements which will be performed sequentially. And finally, there is a return statement that signifies the end of the program. But now, the situation changes just a little bit. Now you are going to define functions on yourself. That means C stipulates that you have to have a main function in your program. And your execution starts, the compiler starts executing from the beginning of the main function. So even the smallest and the simplest C program that you write, it is going to have at least one function, and that is the main function. But as I said, now it is going to change. Now you can define your own functions. These are called user-defined functions. And such functions can be defined following a certain set of rules. We'll learn about them just a little bit later. But right now, we must emphasize on the point why we should go for functions. And that is mainly because these functions perform two very important tasks. And that is where their advantage lies. First of all, they bring a certain modularity into the code. That means you are going for modular programs. You are breaking up large, complicated tasks into certain small fragments, which are supposedly much more easier to deal with. So here in modular programming, you break large computing tasks into smaller ones. Supposedly, these smaller ones would be independent of one another. They might interact with one another, but they should be independent of one another. And all of these smaller functions or smaller code blocks should perform specific tasks. For example, let's say we have an equation like this. This is a very well-known equation which you might become familiar with later on in this mechanical engineering course. It's a matrix equation where you have this vector u, which may be a displacement vector, which is equal to K inverse. K is a stiffness matrix multiplied by, this is a force vector. So if you are to solve this equation using programs, then you need to break it up into certain smaller tasks. Perhaps you have to calculate the inverse first. So you need, for calculating the inverse of a matrix, you need to calculate the determinant. So you can design your code in such a way that a code block, a function would be specified, would be written just to calculate the determinant. One other code block, one other function would be defined, written to get the adjoint matrix. A code block or a program, subprogram can be written to perform matrix multiplication. So like this, you divide the entire complex problem into certain small modules, and you can develop codes for these individual modules. So that is what is introduced through modularity. It obviously has an advantage that now you have categorized your big program into certain boxes, into modules. So while debugging, checking for errors, it is also becoming easier to locate where exactly you are going wrong, where you have made a mistake. Because the compiler would give you explicit instructions that, or explicit, say, notification that the problem or the error has occurred in this function, in this line. So it is quite easy to locate that and correct or modify those mistakes. And you are certain that now all the other modules that were there, they work in a correct way, in an intended way. So that is the advantage that's provided in modular programming. Another thing that is there is reusability. That means the function that you have written here for one code can be used in some other context, some other kind of applications without repeating the parts of the programming text. So your matrix multiplication subprogram, the function, is available to you. So you can take that function to another code also. Think of a situation that in a big complex code spanning, say, thousands of lines, you need to perform matrix multiplication at 5 different locations. So what is easier? Write the code. Maybe for matrix multiplication, you will write 50 lines of code. So those 50 lines of code, do you need to, or do you want to copy it at 5 different locations? That will only increase your program volume. Alternately, you can save this block, matrix multiplication subprogram, save it as a function. And at those 5 different locations, you can call the matrix multiplication function and it will serve your purpose. So it reduces the program volume. Another advantage that you can think of is that this generation is of parallel processing. So if you are working in, say, some organization where you are developing a big programming module, 5 people, 5 of your colleagues, including you, would be given separate tasks. So that is also an example of modularity. People would be given different tasks. You will develop programs for that particular module only. Now what happens finally? Finally, you put it together. You require a main function, and that will integrate all the modules together. But parallelly, all 5 of you would be developing some different parts of the code. So they will be developing different functions. Not the same main program which contains thousands of lines of code. That is you can say, very cumbersome way of doing programs. So whenever possible, wherever possible, go for functions. Finally, one other aspect of functions is that it enables one to build on what others have already done instead of starting over from zero. We have used printf. we have used scanf in our course. So what are these? These are functions. These are known as library functions, as you will see in the next slide. So what is the advantage of library functions? Somebody has already written it and stored it in the C library. So now if you require to take an input, you know that you can use that scanf function. If you want to print something, you know that that printf function is there in C library. You do not have to start from scratch and develop a program, lines of code to print something, to display something on your monitor. So that is already done there. Square root, you can use that. SQRT, power, POW, power. We have used this function, or sign. So all these functions, they are already written by some expert, and it is stored in C library. So whenever required, you can access those functions and perform the specific task that you want to do. So these are the different advantages of functions. And with that, we can now move on to what are the different types of functions. This I have already mentioned to you that there are two different types, broadly two different types of functions in C programming. The first one is standard library functions, and the second one is user-defined functions. Standard library functions are those that are known as inbuilt functions, already written, saved in C library. So these are called inbuilt functions. Examples already mentioned, that printf, scanf, pow, sqrt, or sign, cos, can. These are all library functions. Now, how do you use these? You have been using these from the beginning, right? From the first class itself, probably, that we have used printf and scanf. How do we use that? We just write it out. Write the name of the function, followed by certain arguments within a parenthesis, and you have the intended result. But it is not as simple as that, because all the details and the definitions about these standard library functions are provided in header files. So to use these standard library functions, you have to include the appropriate header file in the program. Now you understand the importance of writing hash include stdio.h. If you do not provide that header file, your C program, your code will not be able to access printf and scanf. So that creates an obvious problem. So in order to use the standard library functions, one must go for the header files. One must include the header files in the program. For example, printf and scanf are part of stdio.h. pow, sqrt, these are part of math.h. So as long as you copy these header files at the top of your program at the appropriate location, then you are free to use these library functions. However, if you do not use that, if you use a standard library function without including the appropriate header file, of course, you are going to get an error. Program that utilizes certain standard library functions. You can see at the top, you have stdio.h, which has been included. Here, math.h is included, and then you start the main function. So this is the main. How many standard library functions can you identify here? You have printf, 1, scanf, sqrt, printf again. So in all 4 lines of the program, you have taken help of a standard library function. So without these standard library functions, C would not be an user-friendly programming language. So obviously there are advantages of these standard library functions. They work without error because these are written by experts and checked and tested over and over again. They are also optimized for maximum performance. So whenever you use this, if you use the appropriate syntax, correct syntax, then you are not likely to go wrong. There won't be errors arising out of them. They obviously save development time. You can see that finding out the square root of a number is done by doing 4 lines of code. This is the main part of the code, obviously. You can see there are 4 lines in it. If you had to develop a program from scratch without using these printf, scanf, or sqrt, this would have run into probably 500 lines. So of course, using the standard library functions saves you time, saves development time. These functions are also portable, meaning that they run on different types of computer systems. It runs in my computer, it will also run in your computer, in your friend's computer, and they will run on online compilers as well. So these are portable. So these are the advantages of standard library functions, and there is basically no point in reiterating it, that if you do not have these functions, C programming becomes very difficult. So whenever possible, try to take help of standard library functions. Now we come to the other type of function in C, which is known as user-defined functions. Now, standard library functions, the user does not need to write them, obviously. What he needs to do is follow the correct syntax and procedure to invoke those functions, call those functions, and utilize it in his code to serve some purpose. But the user-defined functions, the user needs to write them himself. Now, obviously, there are certain specific, one can say, requirements that need to be fulfilled. Then only you can write or declare a user-defined function. What are the important things to remember in case of user-defined functions? These are the function prototype, function definition, and function call. These are 3 different aspects involved with user-defined functions. In function prototype, you declare a function. What is the type of the function? What are the arguments that are going to be? So this is basically a type of declaration. You remember variable declaration or array declaration? Similarly, in function prototype, you declare a function. Function definition is, of course, where the body of the function is. This is where the task, specific task that needs to be performed is going to be taken up. So that would be at this step. And the function call is, how do you invoke that function? How do you call that function? So these are the 3 things that we need to take care of while using user-defined functions. And they have these given format. In function prototype, it is return type. That means what type of data it is going to return. In case of function call, there is a calling function, there is a called function. The called function returns a value. And what type of value it is going to be? What type? Is it going to return an integer or a floating point number, or is it going to return a character? So that is what is defined here as return type. Then you have the function name. that is the identifier, of course. Function name follows the same rules and regulations of variable name. Following the function name is the list of arguments, the values being passed. We'll learn about that in a little bit. Then you have the function definition. It is almost similar to the function prototype, but notice the difference here. In function prototype, there is a semicolon. There is no semicolon here. After this line is written, the body of the function follows within the curly braces. The function prototype does not have the body of the function. That is just the declaration, letting the compiler know that you are going to be using a function of this name, which returns this type and uses these arguments. But here in function definition, there is the body of the function. That is where the main task takes place. And finally, there is this function call. How do you call the function? You call it by its name. If I want to call you, I'll call you by your name. So if you want to call the function, call it by its name. And that function name is going to be followed by the corresponding argument list. So these would be variables or values that you pass on to the function. Okay, at this point, let me just stop here the explanation and move over to the Dev C++ environment, and let us have a look at an example of an actual function. This function is a program to determine largest number out of 2 inputs. It's a very simple program. I have already written it out. And as you can see that there is the preprocessor directives, the header files, and right here in global declarations, you have the function prototype. Remember that I told you that function prototype is basically declaring the function. So that is what is happening here. This function prototype, int is return type, max is the name of the function, and within the bracket you have the argument list. Not only that, you need to specify the type of the arguments also. So type of these two variables, arguments, are integer type. Now what does it mean? It means that in this main function or anywhere within this group of codes, a function named max would be used and defined, and this function max is of return type int, and it uses 2 arguments of integer type. So that is what is said in this line. That is what the compiler understands as it reads this function prototype. Max function will be used in this program. I should not say will be used. It may be used in this program. It has a return type of int, and it uses 2 integer arguments. Then we move on to the main function. The curly braces are there. This is the body of the main function. It goes as you have seen previously. So the first, there's the declaration, the input, and then you see that this answer equal to max inside parenthesis a comma b. This is the function call. I already mentioned that function would be called by its name. So as soon as you write this name here, that means the function is now being called. Now it is being put into action. But there is something to understand here. What is the function of A and B? these two values are going to be passed. That means as soon as this function call is encountered, as the compiler compiles from this end, from top to bottom, as it comes to this line, it is confronted with the function name. So as soon as it finds the function name, it will jump to the function definition. Here is the function definition. Remember, three things were there: function prototype, declaration, then there is function definition. You can see the function definition right here. And as it is called, the control would jump from here to here. And you can see that this part is almost similar to this one. But again, this semicolon is missing here. And after the first line, within the curly braces, you have the body of the function. Within the body of the function, we perform the task of finding out which of these two integers is the largest number. So that algorithm is quite simple. You take a variable. This is a local variable, which is active within this function body. This result is not present in this main function. It will be present in only this max function. So here you see that if-else statement has been formed. If number 1 is greater than number 2, then result stores number 1. And if it is the opposite, then the result stores number 2. Once that is done, you come to this return statement. Now, return statement
in if and else.
In if and else, I have not put any bracket because there is only a single statement. Okay, if there is a single statement, right, then automatically it means it is part of the if statement. This statement is part of the else statement. It is same as providing brackets. But if there were two lines here, suppose under some circumstances there is also another line, then that bracket is mandatory. You have to put that bracket. Okay. So if there is a single line, you can skip the bracket. But if there are multiple lines, you must provide the bracket. Is that clear?
Yes, sir.
Okay. So here now, following the return statement is this expression result. What it means is that this result value will be returned back to this line. So this is the significance of the return statement. And what is the type of this result? This is int. You must remember that the return type must match with the function type that you have defined. It must match. Otherwise, there may be an error. In best case scenario, there will be some type conversion. The type of the return value will change. In worst case scenario, there will be an error that will be provided. Depends on the compiler. So what happens now? So the result goes back here, and the result is stored in answer. So when you write printf max value is %d, then you are not printing result. What you are printing is answer, but answer contains this result value. So that is why this is going to run correctly. Let's run this. So you have 0 errors and 0 warnings. Let's say 12 and 78. The max value is 78. So that is just a simple demonstration of this a very basic program, and this is how the functions work. Quite easily, I could have written this over here. Instead of this function call, I could have put this if-else statement right here. But that would not have been a modular program. It was a single main function that would have given me the result. For simple programs, it may not matter whether you go for modular or non-modular approach, but definitely modular approach is the way to go if you are doing large scale programs. By the way, one more thing I should mention here is that these values a and b, those are the two integers that I have put in, and within parenthesis you have a comma b. So these values are being passed to this max function. A goes into num1, b goes into num2. That is how it happens. That's how it receives the values that were given as input from the keyboard. This is just a representation of the program that we discussed just now. So I'll skip that part. And let's talk about function prototype in just a little bit more detail. As you know that it is simply the declaration of a function that specifies the function's name, the parameters that are going to be passed, and the return type. So these are the information that are supplied to the compiler. It informs the compiler that the function of that name may be used in the program that is to follow. So here is the return type, function name, and the argument list in the function prototype. And here you have our example. So you can match everything with the statement here that name of the function is there, the return type is there, the int return type is there, and also the number and type of arguments are also present. Now here, I want to mention that argument refers to the variables being passed to the function. That means these will be the arguments, and these are the arguments. These are called local arguments or local parameters. So all these three informations are supplied to the compiler through the function prototype. But there is also this semicolon. Don't forget about that. That is the most common mistake that people make, and it gives an error. And as it's a very small thing, it escapes your mind. You do not keep track of that, and you get confused why this error is coming. Now, one more thing, that this function prototype may not be supplied. It is not mandatory if the user-defined function is defined before the main function. The function prototype itself altogether can be gotten rid of. If you define the function before the main function, where is this max function being called first? It is being called from the main function. Now, before the main function, you have already supplied everything in the form of definition. So this total block is now defined somewhere around here before the main function. In that case, the function prototype may not be required, because all the information is supplied to the compiler in the function definition itself. You have the same thing, right? And you have almost the same, you can say, format for the function prototype and the definition, except for this semicolon. So if you are providing the function definition before the main function, then you can probably get rid of the function prototype. Now we go to function definition and function call. Obviously, the definition contains the, you can say, the heart of the function, where the task given to the function is performed. So this is the format for the function definition. And here is the corresponding example that we have seen just now. All the things are already explained to you. So I'm just going to skip this part and tell you about the function call, which is made like this. That is also explained in quite a bit of detail in the last slide. Now here, what we are doing is basically by calling the name of the function, we are transferring the control of the program to the user-defined function. Now you must keep in mind that the calling of a function, it is not limited to the main function itself. In fact, within the user-defined function, you can call other user-defined functions. So it becomes a tree-like structure. So as you can see here, that by calling the function name followed by the appropriate variables or values in place of the argument list within parentheses, control of the program is transferred to the user-defined function. That is function definition. And within this function definition, if you have called to other functions, other user-defined functions, the same thing would happen again. The control would be transferred to the other user-defined functions. And how do you bring back the control? With the help of the return statement. Or in certain cases, return statements may not be used. In that case, once the body of the function is over, it goes back to the calling function. So the compiler starts sequentially executing the codes inside the body of a function and finally comes to the return statement. It terminates the execution of the function and control is transferred back to the calling function after the return statement. But as I mentioned, return is not mandatory. It is optional. Depends on whether you are returning a value or not. Sometimes you may define a function which is of type void. That means it does not return anything. Think of the main function. It does not return anything. We eventually put a return statement, but it has returned 0. So it does not return anything to anybody. In fact, main function is not being called up by anybody. So the question of returning a value does not arise there. So you can see at the last point that I have made in this slide is the one that I already mentioned, that a function may or may not return a value to the calling function. Depends on the structure of the program or whatever you are trying to accomplish through that function. So here we return to the example of the max function where we are trying to find out the largest number out of 2 inputs. Now there was already one question regarding what happens if I write this num1 and num2 over here. Or I can turn it around and say that what if I write A and B in the max function? Is that going to make any difference? For that, let us see how it happens. The transfer of the value takes place like this. Value of A goes to num1, value of B goes to num2. Here again, you must remember that the types should match. This is int. However, if I had written float over here instead of int, that would have caused an error. So that sort of mistakes you should avoid. Check that you are passing the appropriate type of value to a function. And There could have been more arguments here. So A, B, C, D, like that. It may continue. But similarly, you must have the same number of arguments here within parentheses. Otherwise, it is going to create a problem. Most likely, it will give an error. So the number of arguments should match, the type of arguments should match as well, and the sequence should be maintained. I cannot expect to write B here and A here and expect that B will go to num2. If you write the value first, that first value here would go to the first variable here. Now this is known as call by value. In call by value, a copy is created. That means I have written A, B over here. As soon as it comes here, there would be two copies created. Copies of what? Copies of these two variables. These are called formal parameters. Now I could have quite easily written A here and B here, but those still would have been copies. They are not the original variables. Original variables remain untouched. So I could have written num1, num2 here. That would be in separate location in memory. The variables within the function would be copies of those original variables. So it does not affect the running of the program. So there is no conflict between them. So that leads to the conclusion that you can change the values of these variables within this program, within this function. That would not affect the original values. The original values remain unchanged. I could have simply written here, after the if-else statement is over and before the return statement, I could have written A0, B0. And then when I return here, it would not affect these two values because only a single value is returned. The result value is returned. And these changes have been made at a separate location than the original variables. Those changes are made to these copies that were created. So here in printf, if I write AB again, you will see that the original values would be printed here. Is that clear?
So in general, should we avoid using call by value?
Depends on the program. There is its counterpart, which is called call by reference. Now, the details of this I cannot discuss in this class because it deals with pointers. But at least I can mention the basic principle here. What happens here is that the value of these variables are not passed. What is passed is the address of the variables. So in the memory location, let's say this is the representation of the computer memory. Here I have stored A, here I have stored B. Obviously, there would be some numerical values attached to it. There is a specific address to this memory location. There is a specific address to this memory location as well. In call by value, it does not do anything, it does not have anything to do with the address. It simply passes the values. And once the values are passed within this function, in a separate location, two more memory spaces would be designated for num1 and num2. So as it receives these two values, now A comes here, B comes here. Now whatever calculations are carried out within the function here would be in terms of these two local variables or the copies of A and B. So even if you change these two values in the course of your calculations, original ones are still retained there. There is no change to it. However, that is for call by value. In call by reference, again, let me just draw this schematic presentation. So you have A here, you have B here. Let's say some arbitrary value 7200. This is the memory address of A. This could be 7204. Arbitrarily I have written. So in call by reference, these two values would not be passed. What would be passed is these two memory addresses. So as the addresses are passed, the function would still know that these are addresses, and I'm being asked to locate these two addresses and take the values which are within it. Now the thing is, if there are no copies created here, remember that. Now if you do certain operations here and the values are changed, then the original values are being changed. Again, there are no copies here. We are passing the address of the original values of these variables. So if you change something here, the original values are getting affected. Those are the ones that are getting modified. So here, the originals would change. In call by value, the original does not change because you are operating or working with copies. In call by reference, you work with the original values because you are providing the address of the original variables. So that is the difference between call by value and call by reference. Which is better? Depends on the application. In some places, you might want that the original values be modified. So in those situations, probably you go for call by reference. In other cases where you do not want the original values to be tampered with, you go for call by value. Okay, I hope that is clear.
So in scanf, when we write ampersand beside, so we mean to pass an address.
Exactly. So what we do with this ampersand sign in scanf is we are instructing the program to store the value which is input from the keyboard into the address of that variable. The variable has already been declared, so a specific location has already been kept fixed, reserved for that variable. And the first line itself, you have said int A and B here. So right then, these two boxes, or you can say these two boxes, are created with a specific memory location, at a specific memory location with a given address. Now when you take these inputs, you are instructing that you put the first value, this first value in the location, variable location A, and the second one in location B. That is why we use this ampersand sign. That indicates the address of the bin. So once we get the, let's say the values have been passed, the call by value, we have performed all this, we have got the result, and then the result will be passed back to here. So it will come in place of this max, and as a result of this assignment operator, it is going to be assigned to answer. So the numerical value stored inside result is now stored inside answer. So when you write printf this answer, then the maximum of the two numbers are printed here. So that is what is explained here, that answer receives the value of result. Now this statement has also been discussed previously, that the type of value returned from the function and the return type specified in the function prototype and function definition must match. So these things, the function type must match with the type that is being returned back. You can see that this is int, so all these three actually match, and you should be careful about that. Now there are different types of user defined functions. These are basically the same thing but slightly different, you can say, syntax, depending on whether you are passing a value, whether you are returning a value or not. So at the beginning, you can have a user defined function which does not have any return value. It does not pass any arguments as well. So it looks something like this. As it does not return any value, so we have void type, then function name and empty parenthesis. It does not pass any arguments as well. So it looks like this. So this is the function prototype. The semicolon here, you can identify that as a function prototype. And here you have the body of the function, that is function definition. So void, function name. Here also you have an empty parenthesis. There are no arguments here to be passed. So that is the first type of function. And the second type, no arguments are passed again, but it has a return value. It goes like this. Its syntax is type. That would be the type of the function, maybe int or float or something else, char maybe. Then the function name. Again, there are no arguments to be passed, so an empty parenthesis without the list. Here you have the definition, function name, empty bracket, body of the function. At the end, you will have a return expression. So this type and the type of this expression must match. The third one, argument passed but no return value. You can see now the parenthesis has got a list of different arguments, but the function type is void. And correspondingly, there is no return expression, return statement as well. And finally, there is this argument passed as well as there is return value. So this is the most general type of program where you have the different arguments within parentheses and there is a return expression whose type should match with the type of the function. Now here, regarding the return, I must also mention this, that return can also have certain expressions like this. Let's say we are going for an addition program. So A and B has been passed to this function. I'm not writing the entire part. So C is the one that stores the sum. Then I can write return A plus B, or return A plus B like this, or I can write return C. All are valid. It has to be a valid expression to return. Now, one special type of function exists, which is known as the recursive function. What is so special about recursive functions? These functions call themselves. Now, how does that happen? Here we have an example. You can see that there is this int main, the main function. Certain statements are there. Then a function has been called. This is the function being called. The function name is factorial. So what will happen? It will come here. This is the function definition. From the main function, the control jumps to this function definition. Okay. Now here is the body of the function. Within the body of the function, there would be certain statements again. And then you see that this factorial function has been called again. Now, where is this factorial function being called from? The factorial function itself. So the function calls itself. This is known as recursion. So from here, it will again go back to here. This is a recursive function call. The previous one was a normal function call. This is a recursive function call. Such programs can be written in C, and they are sometimes a sort of elegant sort of programs. But can you identify a problem here? This is not the whole program, definitely, just the syntax part. But from the nature of the calls, the recursive function calls specifically, can you identify any problem with this? Anybody? When is this going to stop? This is sort of forming a loop, isn't it?
Yes, so we have
It
to
is
give some
forming some
condition
kind of
where
a loop.
it has to.
It has to be given a particular condition where it stops calling itself. Otherwise, it becomes an infinite loop, isn't it? It comes here,
Yes, sir.
comes here, it will call itself, and it will go on forever. So when does it stop? So usually what is done is that recursive function calls are provided as part of an if-else statement. So you have two branches. Obviously, at the beginning, you have a condition check. Then you have two branches, true and false. So the recursive call would be provided on one of those two alternate branches, so that at a certain condition, the condition check would return a false value and it would end the recursive function call at that point of time. Otherwise, it creates an infinite loop. So recursion continues until some condition is made to prevent it. The same point is explained over here. You can see that to prevent infinite recursion, condition check, that is if else, can be used where one branch makes the recursive call while the other doesn't. So finally, when the condition does not satisfy, it returns a false value. It has to stop calling itself. Here we'll write the recursive function. So demonstration of a recursive function. Here we will calculate the factorial of an integer using the recursive function. Now, calculation of a numbers factorial, integers factorial, that program has already been done. But that is done through a simple main program. Now we'll do this through a function call, not a simple function call, a recursive function call. So let us start. So you have the preprocessor directive here, so that's not a problem. Here what I will provide, I'll write long because long integer I'm defining the function type as, because in factorial you might have to deal with very large numbers. So that is why long is provided. Let's give a name, simple name, factorial. That's what we have used in our presentation. So int n. Don't forget the semicolon. So this is the function prototype. Declaration of the function is done. Now we go to main. Here we write int n, and let's say long act, another variable that I have taken. Printf enter an integer, that is the prompt to the user that he has to enter an integer. Maybe write it as positive integer, more specific. You write scanf write percentage. So this is d. We are taking input of an integer. The address n. That does it. Next, we will call the factorial function. Fact equal to factorial. That is the name of the function. And within bracket, we'll have to provide the argument. What we are passing is the integer n. For that, I want the factorial. I'm going to develop the user-defined function just a little bit later. Right now, let's write the printf. Just copy it from here, put it here. Instead of this, now we have to write and display the factorial. So let's write it like this. Percentage d factorial sign equal to percentage ld. Ld is for long integer. That is the type specifier. You have n and you have fact. So I think that is all in terms of the main function. But now I have to define the user-defined function. So that is the function definition. The factorial, then within bracket, I'll write int n. What we have done, see that this is n, This is also n. We are using the same thing, but it will be a copy. Remember that. The braces. It's the local variable, local to this factorial function that I'm going to define. And then I'll put if n is greater than equal to 1, then here I'll put the braces because I need more than one statement. So I'll write mult here. That is the variable that I defined, equal to n into factorial n minus 1. Then I'll return that is the if part. Within else, I'll write return 1. And that's all. So this is the factorial function. This is where there is a recursive call. How the execution happens? I input an integer here. That integer will be passed to this function, factorial function of this call. So directly it will come here. Now if it is more than 1, let's say we have come with the value of 2. Simple example, 2. So it goes inside this. This is 2 multiplied by factorial 2 minus 1. So this is factorial 1. As soon as it encounters that statement, it will go here. Now with n equal to 1. Comes here again, n is equal to 1. So the condition is satisfied. It will be mult equal to 1 into factorial 1 minus 1. That is 0. So it will again go here. But this time, because n is 0, it does not go inside this. It will come to the else statement. And it will find that the return value is 1. So it will go back with that return value to the previous step where it was n into factorial 0. Now that becomes n into 1. And that n is returned, that, sorry, not n, that mult is returned to the previous statement, which was factorial 2 minus 1. So like that, it will jump back several steps, appropriate number of steps, till it reaches the final value here, and that will return back to this fact. Let's see if it runs. Okay. We'll print factorial 5. You can see that 5 factorial is 120. Test again, maybe with much 4. So this is 24. So this is how the recursive function works. One disadvantage of recursive function is that they are quite slow in terms of computation time. So if the same task can be done with nested for loops, it's always better to go for nested for loops instead of going for recursions. Recursions usually have quite a lot of applications in data structure. But data structure is not the main focus in mechanical, of course, in mechanical engineering applications. So here the applications are somewhat limited. But definitely, if you find the appropriate occasion, appropriate application, you can go for recursive functions. Okay, so I hope that explanation was quite clear to you. I will obviously send the program back to you as well. But for now, let us just continue with this and go to the final slide that simply states that it is possible to pass an array to a function. In the last class, we have learned about arrays, and I have sent you quite a bit of material relating to different programs in arrays. So it is quite possible to pass an entire array to a function. And what is required is only the name of the array to be passed as an argument. So you just put the name of the array there, but followed by the square brackets. In the function definition, one must use these square brackets to indicate to the compiler that an array is being passed. So you write it like this. So float, that is the function type, function name, within bracket, in the argument list, you define the type of the array and then the array name. Let's say here it is given as array1 followed by the square brackets. You can also provide the size of the array within the square bracket. Here I have not done that, but that is also allowed. That can be done. And finally, you have the body of the function. But one very important note that you should remember is that arrays cannot be returned from a function. You can pass single or multidimensional array to a function, but you cannot return them. The return value cannot be an array. It has to be a single value. So that obviously begs the question that how do you, if you have written some function, subprogram, which deals with an array, then how do you return it back to the main function? That can be done using pointers. You have to use pointers. In pointers, you deal with address of the variables or arrays. So you can return back the address of that array to the main function. Address, obviously, array address is the address of the 0th one. That means 0th index. That is the first block of the array, or the first space of the array, and that address is the address of the array. So if you can return it back to the main function, then you can, as someone mentioned, that then you can use maybe for loops to retrieve the values that are residing in the array locations, different blocks of the array, different elements of the array. So obviously some background reading is required for this. I have not given too much detail over here. So if you are interested, you can go to certain textbooks, and any C textbook would be having a chapter on the relation between functions and arrays and how to deal with them. So you can refer to that. So that brings us to the close of the discussions for today's class. And I thank you for your attention.